Welcome everybody, it's Ramchandra from Civil Mech Maths Concepts. Today, in this lecture of Structural Analysis 5, I brought very important lecture on the concept of finding moment of inertia of any particular shape, of any shape of beam, especially with respect to mechanics of materials and strength of materials. This particular concept and this particular topic was chosen even though the structural analysis I have completed 4 chapters, 4 lectures, in which I thought of developing concepts for the numerical problems. In the structural analysis 5, I dropped that numerical problem, but I wanted to clarify before starting the numericals in structural analysis to study the calculations and the concepts of calculations very clearly before attending the numericals. The mechanics of materials and strength of materials, the concepts, the calculations, the formulae, the basics, they are very much required for further forwarding for completing the structural analysis course. Structural analysis course is a very vast course. It requires concepts from strength of materials and also concepts from mechanics of materials and also the concepts from differential equations, integral calculus and also some mathematical basics. Then I thought it will be prudent for me to bring in some additional concepts before starting the numericals on structural analysis. Even though this subject is mainly structural analysis only, the main structural analysis subject deals with finding the stress in a particular part of the member and to find whether it is admissible or not, whether it is within the allowable limit or not. For finding the stresses of allowable quantities, there are codes across the world. Euro code is there and also Indian codes are there, and from the codes for the given material, from mechanics of materials and strength of material basics, we can find the allowable stresses, and from then by applying the beam theory, which is written as M by I is equal to sigma by y is equal to E by R, we will find out the applied stresses, and the applied stresses and the allowable stresses are compared so that a particular member, whether it is crossing a particular stress level which is available at a particular section, so that whether this particular member is suitable in the design or it's not suitable, whether it requires a redesign is to be found out. The beam theory is very important. The formula of beam theory, M by I is equal to sigma by y is equal to E by R, is very important, in which E is the Young's modulus, M is the bending moment, and Young's modulus for a particular material is constant, and sigma is the stress applied at a particular point, and I is the moment of inertia, which is the critical, which involves critical calculation, and y is the distance from the neutral axis, r is the radius of curvature. With this background, I thought it will be prudent for me to go for the portion in the beam theory which requires the critical calculations like a moment of inertia. The moment of inertia of a beam depends upon its cross-sectional shape. There are regular cross-sections such as rectangular, square, circle, semicircle, but in this particular class I have taken, in this particular lecture I have taken a beam with a cross section in the form of sine curve. There are different types of beams are there. I cross section beams, T section beams, circular beams, semicircular beams. They are all regular, but instead of that, they are available in all the books, textbooks. I have taken the cross section in this lecture as sine curve, in the form of sine curve. Cross section is in the form of sine curve for this particular beam which I have chosen for this lecture. And this lecture will be useful for all types of examinations, both descriptive examinations and also multiple choice questions based examinations at both national level and international level. I will be taking up a general case. It's a typical case. I have taken sine curve. You will appreciate why I have taken this and why I have chosen this and how I have calculated, so that you will very comfortably understand the concept and do the regular shape calculations with ease. Once you do the tough job, which involves finding moment of inertia for a non-familiar beam shape, then you will be very easy, you will be at comfort to find the moment of inertia of familiar shapes like circle and rectangle. These will be, as I told you, these will be useful for FAPE examination, GATE examination and also SSC JE exam. In the SSC JE exam and in the other examinations, when multiple choice questions are asked, the total theory may not be asked, but however, understanding the theory, understanding the concept behind deriving the expressions and equations in structural analysis will give an added advantage that you will not miss out on the exactness of the answer being put in the examination for the given question. Question can be of any type. When you know the concept, you will be able to answer it perfectly well. And in this, as I told you earlier, I am going for a general case. And this, whatever I discuss here, this particular discussion can be applied with ease and confidence to any shape of the beam. It need not be for sine curve shape, it need not be for I shape, it need not be for T shape or a circular shape or a semicircular shape. The concept which I am going to discuss in this can be applied with confidence in any shape. That is, moment of inertia of any section can be found out by using the concepts developed in this particular lecture. Now, before dwelling into the details, the sine curve has a breadth of 2b along the x-axis starting from origin O to 2b on x-axis and having a variable height from 0 to maximum height at center at h. Here the height is not constant, it is varying. That you should make a note of it. In a rectangular shape, the height will be constant. Let us take any irregular shape, for example, any irregular shape. And first and foremost point to be remembered is to find the area of the shape. What is the area of the shape? If the shape of the object is y in a form y is equal to function x, y is equal to fx, then area will be double integral dy dx. What is dy dx? Let us show in the diagram here. What is dy dx? Dy dx will divide this particular shape into very small portions, and a small portion of can be treated as dA. The value of that small dA is nothing but dx into dy. Area of the dA is added whole together and make area A. double integral of dy dx, as I told you previously, that is equal to area of the shape. Integral of dy is equal to y, that is integral of y dx is the area of the shape. Let's not put the limits at the learning level. This is a formula which we have developed for any shape. We have taken any shape. It's not that we have restricted ourselves to a particular shape. We have taken any shape. Area is dA, which is equal to dAd. Then we have to find out first moment of area. We have found out the area. Now first moment of area we have to find out. What is the first moment of area? Moment is nothing but something into distance. First moment of area is area into distance. Like moment of force is nothing but force into distance. P is equal to F ds. In a similar way, first moment of area is equal to area into distance. What is the area? And what is the distance? With respect to x-axis, we are calculating everything. Because moments also, they require a axis of reference. With respect to x-axis, we will be doing it. Please make a note of it. That what is the area? Area is y dx or double integral dy dx. And when you use the double integral, that is, a distance is y, dy dx is area. That is double integral y into dy dx is the first moment of area. What is the value of integral y dx, y dy? Y dy is nothing but y square by 2. These are all things intuitively should be coming to us. Then we have to find out the center of gravity of a shape. What is the center of gravity? The general definition is first moment of area divided by area. That is the center of gravity of a shape. Very, very important concept. It's applicable for all shapes everywhere. What is first moment of area? Double integral y dy dx divided by integral double integral dy dx. This is a very important formula, applicable for all cases. Now we will move further. Area of the shape we have found out. First moment of area we have found out. And we got the formula for center of gravity of a shape. For any shape, need not be a regular shape. And once we are equipped, and the center of gravity either can be shown as yc, represented as y bar, and in the given shape, let us see how it can be represented. Take x-axis, and at a height of y bar or yc, there will be parallel to x-axis. One point will be there, that point is center of gravity. With respect to x-axis, the height of the center of gravity is equal to y bar, that is equal to yc, that is equal to double integral y dy dx divided by double integral dy dx. Then fourth point, let's go for. We have to find out ultimately the moment of inertia of a shape. Moment of inertia can be found out with respect to x-axis and also with respect to center of gravity. With respect to x-axis, that is Ix is equal to double integral y square dy dx. In first moment it is double integral y dy dx. In moment of inertia it is double integral y square dy dx, a very important formula. This is called as the second moment of area. The second moment or the moment of inertia of a shape with respect to x-axis is equal to double integral y square dy dx. Very important formula. Please keep a note of it. It is applicable for any shape. Then this is with respect to x-axis. Now, usually with respect to center of gravity has more applications in engineering as through center of gravity the neutral axis passes. Neutral axis is the axis where stresses and strains they change the sign. Then moment of inertia with respect to CG is equal to double integral y minus yc whole square dy dx. This is by using the parallel axis theorem. Moment of inertia with respect to x-axis is double integral y square dy dx. With respect to center of gravity is double integral y minus yc whole square dy dx. We have already found out yc, that value you can put in the center of gravity equation and you can find out the value moment of inertia with respect to center of gravity. Now, let's move on to the application of these equations or these basic concepts to the given problem. Let us draw the given curve, x-axis, y-axis, sine curve, starting from origin to distance 2b on x-axis, that is the breadth of the sine curve, with maximum height h. Let the sine curve be represented as in this figure. It is resting on its base as x-axis and the beam is a solid beam with a curved shape instead of a rectangular beam, starting from origin above 0 0 to a distance of 2b, that is breadth on x-axis, and height h, maximum height. It is the maximum height because it is in the sine wave form. In the sine wave form, what happens? Height starts from 0 to maximum h, and there will be a center of gravity for the solid beam. Center of gravity, let us say it is CG, at a height of y bar or yc from x-axis. Now, with the basics what we have learnt previously, let us try to apply them here one by one. Here only two parameters are given. The maximum height attained by the sine curve is h and the breadth of the beam is 2b. Now what we have to do? Find moment of inertia I of sine curve beam with respect to x-axis and Ixx and with respect to center of gravity, that is ICG. Let us try to find out this. Our ultimate aim is to find the moment of inertia. How to proceed? There are 4 steps or 5 steps to be followed, 4 steps minimum. First we have to find out the area of the curve. From the previous discussions, we can see that the area of the curve is equal to either double integral dy dx or integral y dx. To find out that double integral dy dx or to find out integral y dx, we require the limits on x-axis from which place to which place, which point to which point, and the y-axis, the sine curve should be developed as a function of x, as explained earlier. That let us say y is equal to h into sine pi x by 2b. This is very important formula. You have to keep in mind. Here 2b is the total breadth and h is the maximum height achieved, sine pi x by 2b. This is what is the sine curve equation, and let us see the validity of it. Before applying this particular equation, we have to check the equation for boundary conditions. Let us say if x is equal to 0, y is equal to h into sine pi 0 by 2b, that is sine 0, that is equal to 0. If x is equal to b, y is equal to h sine pi 2b divided by 2b, that is equal to sine pi, which is equal to 0, h into sine pi, that is equal to 0. That means the end boundary conditions are fulfilled. At the starting point for x is equal to 0, y is equal to 0. For the ending point for x is equal to b, y is equal to 0. Now BCs are satisfied. Once these boundary conditions are satisfied, for the value, middle value, when x is equal to b, if you apply y is equal to h into sine pi b by 2b. That means y is equal to h into sine pi by 2. What is the value of sine pi by 2? That is 1. That means y is equal to h into 1, that is equal to h. That means the other condition also is fulfilled. Hence this equation of y is equal to sine h into sine pi x by 2b can be taken without any issues for satisfying the boundary conditions. So that this equation can be safely taken as a function, y as a function of x. Y is equal to h into sine pi x by 2b. If pi x by 2b is equal to some ax, then it can be written even as a y is equal to h into sine ax. That means as h and a are constants, we can say y is equal to some function of x. Y is equal to fx, that is equal to h into sine pi x by 2b. Now, let us try to apply in the formula and find out the area of the curve. A is equal to double integral dy dx, that is equal to integral y dx. Let's not put the limits immediately. That is integral. What is y? H sine pi x by 2b. Into dx. As I told you just now, sine pi x by 2b is in the form of sine ax. H is a constant. Here, because it is in the function x formula, we can put the limits safely 0 to 2b. Except x, all others are constants. So it is in the form of function x. Then x varies from 0 at the origin to the other end to 2b. So that limits are put safely 0 to 2b. Area A is equal to integral 0 to 2b h sine pi x by 2b dx. That is equal to area is equal to h into integral 0 to 2b sine pi x by 2b. This can be safely written. Then integral of sine ax is equal to 1 by a into minus cos ax. That is the integral. That is a standard integral which you all should be aware of from the preliminary calculus, which is the requirement for understanding this course. As per preliminary calculus, integral of sine ax is equal to 1 by a into minus cos ax. Integral of cos ax dx is equal to 1 by a sine ax. Now it can be written as area cannot be negative, we put the values in integral values in absolute terms, that is equal to h absolute terms 2b by pi. What is a here? Ax means pi by 2b. That means 1 by a is 2b by pi into minus cos pi x by 2b, limits ranging from 0 to 2b. Here, for further better understanding, I provide a more simple basic formula. Integral sine ax dx is equal to 1 by a minus cos ax into. Similarly, this is a very important formula. It has a lot of engineering applications. Similarly, we can take this also, cos ax. Before that, let us say sin pi x by 2b dx integral is equal to 1 by a means 2b by pi minus 2b by pi into cos pi x by 2b. This is the value of this particular integral. Now, similarly, this also y minus sin has come because integral sin x dx is equal to minus cos x. Hence, area is equal to integral to bh by pi minus cos pi x by 2b. This is here. Pi x by 2b, limits ranging from 0 to 2b, that is equal to 2bh by pi into minus cos pi into 2b divided by 2b minus of cos pi into 0 divided by 2b, close absolute. Here, to understand the concept of cos 0 and cos pi, I have explained everything in gate engineering mathematics. Then area is equal to 2bh by pi into. What is minus cos pi? 2b by 2b is minus cos pi, because 2b gets cancelled. Then what is the value of minus cos pi? In which quadrant it comes? What is its value, whether positive or negative? Everything I have explained, especially in gate engineering mathematics by IIT alumni. That is the playlist name under my channel, Civil Mech Maths Concepts. Now, let us try to evaluate cos 0 and cos pi. Cos pi and cos 0, they are numerically 1. In the quadrants, all silver teacups, which I have explained clearly. All is in the first quadrant, silver is in the second quadrant, tea is in the third quadrant, cups is in the fourth quadrant. All means all trigonometric identities are positive in the first quadrant. Silver means sine is only positive. The trigonometry is sine is positive in the second quadrant. Pi means that comes in the second quadrant, hence cos pi is numerical value is 1 and with sign minus, because cos is negative. Minus cos 0 is 1, that means minus cos 0 is minus 1. That means in the absolute value is 2bh by pi minus of minus 1 minus of minus 1, that is equal to 2bh by pi into 1 plus 1, that is 4bh by pi. This is the value of the area of sine curve. The value of the area of the sine curve is equal to 4bh by pi. This is a very, very important formula. In multiple choice questions, if something comes like this, you put for a sine curve, it is 4bh by pi. This value can be asked, maybe. And that implies A is equal to 4 by pi is nothing but 1.273 bh. It is for a sine curve of breadth 2b and height h, variable height h. That is 4 by pi into bh. For the similar rectangular shape, for 2b breadth and height h, it will be 2bh. That means the area of the rectangular is more than the area of the sine curve. That you should understand. This is one of the concepts. You just see it is 2b where height is h. People get confused. BH means rectangle. No. The breadth is 2b in sine curve. If breadth is the same equivalent rectangle to be taken, the breadth should be 2b, not b. Please try to understand that. When you fill the total rectangle, the rectangle area will be more than the sine curve area. When you take breadth as 2b and height as h. This is a typical confusing type of question. You people should be able to understand it. 1.273. Let's now move on to find the first moment of area. That is equal to integral y dA. What is first moment of area? That is distance into area into distance or distance into area. That is equal to integral y dA, that is equal to double integral y dy dx. Now, either we can put the value of y directly and find out this first integral, or double integral y dy dx. Y is sine h into sine pi x by 2b into dy dx we can put. Otherwise, we can even do it without converting everything in terms of x. That is double integral y dy dx. What is the integral value of y dy? That is y square by 2. How we have got it? You see, integral y dy is equal to y square by 2. That is equal to, because integral y to the power of n dy is equal to y to the power of n plus 1 by n plus 1. It's a very important formula, please remember. Now, by replacing that integral y dy as y square by 2, we will get first moment of area is equal to integral y square by 2 dx. That's nothing but integral 0 to 2b. Here we can put the limits because y square we can get it in x form. We know it. 0 to 2b 1 by 2 into h sine pi x by 2b whole square dx. That is equal to, h is a constant, h square by 2 integral 0 to 2b sine square pi x by 2b dx. Here there is a relation between sin square x and cos square ax, which we can write as, from the prelims of trigonometry, cos square x minus sin square x is equal to cos 2x. From which, it's an important formula, from which cos square x is equal to half into cos 2x plus 1. Since sin square x plus cos square x is equal to 1. That is from the basic Pythagoras theorem. Similarly, sin square x is equal to half into 1 minus cos 2x. These two equations, cos square x and sin square x, and the relation between them for cos 2x are very important and everywhere applicable for engineering calculations. Be thorough with them. The next important formula are integral sin ax dx is equal to minus 1 by a cos ax and integral cos ax dx is equal to 1 by a sin ax. These are the very important formulae which you have to remember while doing the problems in structural analysis you encounter regularly. Now, with this concept, we will write what will be the value of sin square pi x by 2b, that is equal to half into 1 minus cos 2 into pi x by 2b, which implies sin square pi x by 2b is equal to half into 1 minus cos pi x by b. Now, with this formula in hand, let us find out the first moment of area for a sine curve shaped beam. First moment of area for sine curve is equal to integral y square by 2 into dx that is equal to h square by 2 integral 0 to 2b, let us see, sin square pi x by 2b is nothing but half into 1 minus, that is sin square pi x by 2b dx, which is nothing but the derived value in terms of cos 2a, that is equal to h square by 2 into integral 0 to 2b, the derived value for sin square pi x by 2b is half into 1 minus cos pi x by b, half into integral 0 to 2b, half into 1 minus cos pi x by b dx, that is equal to h square by 4 which is the constant taken out of the integral, that is equal to h square by 2 into half is equal to h square by 4 into integral 0 to 2b. Let us separate the integrals, additions and subtractions, 1 into dx minus integral 0 to 2b cos pi x by b dx, that is equal to h square by 4 into, here we have whatever subtraction is subtraction we have done and individually we have calculated. What is integral 1 dx? That is equal to x, that also you have to remember. Integral of a constant is equal to integral of a dx is equal to a dx is equal to ax. Similarly, integral of 1 dx is equal to x, that also please remember. And then this value becomes h square by 4 into x with limits 0 to 2b minus 1 by a. 1 by a means 1 by pi x by b. A is pi x by b into sine pi x by b. Limits 0 to 2b. That is equal to h square by 4 into, when you apply the limits in the final equations, we will get 2b minus 0 for x and for the other value minus b by h into, because 1 by pi by b is nothing but b by h, into sine pi 2b by b. Be very careful in writing these equations so that you will not make the mistake. Minus sine 0 pi by b when limits are applied. That is equal to h square by 4 into 2b minus b by pi into sine 2 pi minus sine 0. Here you have to know the values of sine 2 pi and sine 0. Sine 0 is equal to 0. Sine 2 pi is equal to 0. These values I have explained in my GATE engineering mathematics, trigonometry. Well, you can refer to that lectures. Then this value becomes the final value of first moment of area for a sine curve is equal to h square by 4 into 2b minus b by pi into 0 minus 0. That is equal to h square by 4 into 2b minus 0, that is equal to h square by 4 into 2b bh square by 2. This is the final answer for first moment of area for a sine curve. Even though it's a little bit tedious to do it, if you do it with consciousness, you will definitely get the correct answer, and at the same time you will be able to answer it correctly in the examination also. Please remember the values which we are deriving in this particular question to get the confidence for any shape, given shape in the examination. Now, let us move on to center of gravity of the sine curve. We found out area, we found out moment of the area. Now, let us go for the center of gravity of the curve. From the definitions, what is the center of gravity? Center of gravity is nothing but first moment of area divided by area. That is center of gravity. The height of the center of gravity above x-axis, that is equal to double integral y dy dx by double integral dy dx. That implies that is equal to first moment of area by area. Hence, center of gravity is equal to, let us draw xy plane and show the sine curve on the xy plane. Let us approximate the center of gravity SCG at a height of y bar from x-axis. This is with respect to x-axis. With respect to y-axis, it will be different. Moment of area. Whatever we have derived till now is with respect to x-axis. that is equal to double integral y dy dx divided by double integral dy dx. This is y coordinate of the center of gravity. Let us see the values. First moment of inertia is bh square by 2. Whole divided by, what is the area? Area is 4bh by pi. Let us do a little bit of algebra. bh square by 2 into pi by 4bh. bb gets cancelled. 1h above and 1h below is gets cancelled. That is equal to pi h by 8. This is the value of y bar or the y coordinate of the center of gravity, that is equal to y bar or yc, that is pi h by 8 for a sine curve. Please remember this value, very important. This can be approximated as pi by 8 is constant, that is 0.393 into h. This is how the center of gravity of the sine curve y bar, that is pi h by 8 and 0.393 h, as shown in the figure which we have drawn. We have shown it. Now, 3 steps are completed fully. Area is calculated, moment of area is calculated. From area and first moment of area, we have calculated the center of gravity of the sine curve, that is height from the x-axis of the sine curve in terms of maximum height reached by the sine curve. Then next comes moment of inertia of sine curve with respect to x-axis. Here everything, all calculations we are doing with respect to x-axis. Ixx is equal to double integral y square dy dx. We know the value of y in terms of x. Y square dy, let us first clear off. Y square dy is nothing but y cube by 3. Ixx is equal to double integral y square dy dx, whereas first moment of area is equal to double integral y dy dx, y dy dx, double integral, that is first moment. Second moment is double integral y square dy dx, that is equal to integral of y square dy is nothing but y cube by 3 into dx. Here let us not worry about the limits, now we will put the limits. 0 to 2b, h sin pi x by 2b, that is y, that is cube, it should be made cube and to be multiplied by 1 by 3 into dx. This value has to be calculated. For that, here we will calculate Ixx is equal to 1 by 3 integral 0 to 2b sin cube pi x by 2b dx. h into sin pi x, it is not, h cube. Ixx is equal to 1 by 3, 0 to 2b. H cube to be added. By mistake it is not added. Now let's add h cube. That implies Ixx is equal to h cube by 3 into integral 0 to 2b sin cube pi x by 2b dx. Here we have to find the value of integral sin cube pi x by 2b dx with x limits from 0 to 2b. That is the most important formula and most important thing to be done now. Integral 0 to 2b sin cube pi x by 2b dx is equal to 8b by 3 pi. That is the standard value. I am not going into the process of integral evaluation that you can do from your basic calculus knowledge. You take it as the homework for you. This homework can be useful for FE, PE or GATE examination where engineering mathematics is also involved and to be prepared for. And with this background, we can finally say that with respect to x-axis, the moment of inertia is Ixx is equal to h cube by 3 into 8b by 3 pi, that is equal to 8 by 9 pi into bh cube. This is the most important value of a sine curve beam, the moment of inertia with respect to x-axis. Now, here in this example, engineering mathematics and the concept of moment of inertia both are clubbed together, so that for that reason only I have taken this as an important application of moment of inertia in finding the stresses in the beam for calculation of moment of inertia. And this particular, with respect to x-axis, this particular value can be written as 0.283 into bh cube. This value, please remember, 8 by 9 pi into bh cube, that is equal to 0.283 into bh cube, where 2b is the total breadth of the sine curve and h is the maximum height of the sine curve. When total breadth of the curve and height of the maximum height of the curve are given, we can find out the moment of inertia with respect to x-axis as 8 by 9 pi bh cube, that is equal to 0.283 bh cube, 0.283 bh cube. Please remember these values. Now, let us switch over as a fifth point to find out the moment of inertia about center of gravity. ICG is equal to how much? Because center of gravity is the most important point. ICG is equal to, as per from definitions, double integral y minus yc whole square into dy dx. That is the value. Then what is the value of yc? It is a constant. That is equal to pi h by 8. that is equal to 0.393 H. That is the value of YC. By substituting this value or without substituting, let us derive the formula, then we will substitute. Now, let us derive the formula for ICG. That is equal to double integral y minus yc whole square is a minus b whole square, a square minus 2ab plus b square. Double integral y minus yc whole square is equal to y square plus yc square minus 2y yc, where yc is y coordinate of the center of gravity with respect to x-axis into dy dx. Now, let us expand the integral, total integral, bracket, integral of y square dy dx, y square dy, let us keep dx outside, let us operate with dy first, plus integral y1 square dy, yc square dy, minus 2 into yc dy, and whole bracket, next operator dx to be used. The first operator is dy, we will operate with dy and find out the integral. That is equal to total integral, within the brackets the value will be y cube by 3, because integral of y square dy is y cube by 3, plus y1 square, because integral of constant into dy is equal to y yc square, not y1, it is yc, sorry, minus 2 into y square by 2 into yc, because integral of y dy is y square by 2, the whole bracket closed into dx. That is equal to integral of y cube by 3 plus yc square minus y square yc dx, whole dx. Here y is equal to h into sine pi x by 2b. Now let us substitute that value in this equation, then ICG is equal to integral of, we will put the limits also for x, 0 to 2b, y cube by 3 is nothing but h cube by 3 into sine cube pi x by 2b, minus plus y is nothing but sine pi x by 2b, h into yc square, minus y square is nothing but h square bracket sine square pi x by 2b into yc, the whole bracket of this result with the operator dx. Then this whole value we have to calculate. These are differential integrals, not differential integrals, they are definite integrals. They have specific value. Please look for definite integrals in any standard textbook like Advanced Engineering Mathematics by Krasjig. Get the answers. This integral of 0 to 2b h cube by 3 into, when we take out constants, sine cube pi x by 2b into dx minus h square into yc integral sine pi x by 2b dx plus hyc square Sin pi x by 2b in the previous one whole square dx plus h yc square integral sin pi x by 2b dx. I was slow here because I don't want to make any mistake. Now, this is the final derivation. We have to find the integral values. From the basics of definite integrals, already we have found out for the first integral, that is 8b by 3 pi, integral 0 to 2b sin cube pi x by 2b dx is equal to 8b by 3 pi. Next integral value, integral sin pi x by 2b whole square dx from 0 to 2b is b, that value is b, plus next integral sin pi x by 2b dx from 0 to 2b is 4b by pi. You put the limits in the second, both two last two integrals. I have forgotten to put the limits. The values also you calculate as a homework. Now, moment of inertia of sine curve is equal to second moment of area of a sine curve about center of gravity when the base is on x axis as in the figure. Let's draw the sine curve beam and show it in the diagram. X axis is the base and CG is the center of gravity point. That is y bar. We can even say it as yc. And we have to find out the moment of inertia with respect to CG. ICG is equal to, from the previous values, from the previous slide, if we translate those values, ICG is equal to h cube by 3 into 8b by 3 pi minus h square b into pi b by pi h by 8 it's just nothing but substituting the values, because y bar is pi h by 8, we have taken that value y bar, plus pi h by 8 whole square, yc square means pi h by 8 whole square into 4b by pi, that is the integral value. By simplification into h. Let's not miss even a small parameter. By simplification, ICG is equal to 8 by 9 pi into BH cube minus just to see how we can simplify, pi by 8 into BH cube plus BH cube into pi square 4 divided by 8 pi. Pi get cancelled and 1 pi remains on the top, and 4 gets 8 into 8 pi, 4 divides 8 gets divided by 4 to 2, 8 into 2 is 16. Then ICG is equal to, in simplification, 8 by 9 pi BH cube minus pi by 8 into BH cube plus pi by 16 into BH cube. From all this we can take BH cube as common. ICG is equal to BH cube into 8 by 9 pi minus pi by 8 plus pi by 16, that is equal to BH cube into 8 by 9 pi minus pi by 16. Therefore, about the center of gravity ICG for a sine curve is equal to BH cube into 8 by 9 pi minus pi by 16, which is equal to 0.0866 BH cube. This is a very important formula which, if required, you may have to derive it in the examinations like ESE or UPSC examinations or any other examination. Otherwise, for multiple choice, you can remember the value. This is the about center of gravity. The values of moment of inertia about center of gravity have more relevance in engineering rather than about the x-axis. The reason being, the neutral axis passes through the center of gravity, and neutral axis is defined as the axis on which there is no strain. The neutral axis, it is same line, it is straight previously and afterwards also. After bending, it remains straight. Hence, for a sine curve, the final results are as below. Area is equal to A is equal to 4BH by pi. Let us draw the sine curve. Sine curve is drawn. It starts from origin 0, 0, ends at 2b 0 with maximum height h and center of gravity at y bar. For this geometry, area is equal to A is equal to 4b h by pi. First moment of area. Next value what we found? First moment of area is equal to BH square by 2. Third value is center of gravity, that is the y-axis height, y-axis coordinate, that is y bar or yc is equal to pi h by 8. That is with respect to x-axis. Then with respect to x-axis, moment of inertia Ixx is equal to 8b h cube by 9 pi fifth value we found is moment of inertia about center of gravity ICG is equal to bh cube into bracket 8 by 9 pi minus pi by 16. These are the final values of moment of inertia of a sine curve, and the numerical values will be Ixx is equal to 0.283 bh cube as derived earlier, ICG is equal to 0.0866 bh cube, center of gravity, that is height, y-axis height, point height on y-axis above x-axis is 0.393 h. These are the values which either you may have to derive if sine curve is asked, if it is a descriptive question paper, or you may have to remember them either in pi values or as a numerical values, combination of pi and numerical values. And if a problem is given or a question is asked, what is the Ixx for a sine curve beam in the sine curve shape, then Ixx is equal to 8 bh cube by 9 pi. That answer you should be able to give. There can be many questions on this. Many questions can be taken. They may ask you in the examination to compare the value of sine curve with the circle shaped curve, with the parabolic shaped curve. And as a homework, I want to give you one question. Find out Iyy. Whatever I found out here is Ixx. Now find out Iyy. That means moment of inertia with respect to y-axis. Iyy is how much with respect to y-axis. With respect to x-axis we have found y bar. Then Iyy, it involves x bar. Find out that. I will give the final answers. Please cross check with your answers. Iyy is equal to 0.241 hb cube. Height and breadth interchange in y-axis. We can even write it as 4 by pi minus 32 by pi cube into hb cube. H and b are interchanged, but the values are different. Please do it as a homework so that it gives a practice to you. Go in the similar manner in which I have explained you. Area is integral y dx, then moment of area is integral y dy dx, first moment. Second moment is double integral y square dy dx, double integral, so that we can find out. And also in homework, compare all these values with a semicircle. These values I have got for sine curve. Calculate the same values, similar values for a semicircle. It is resting on the diameter. Diameter is on the x-axis. For a semicircle, you find out the values of area, first moment of area, second moment of area, center of gravity, Ixx and Iyy. Homework for practice is, please do it without fail. Find area. B. First moment of area. C. Moment of inertia or second moment of area. Ixx and ICG, Iyy, both. moment of inertia D is moment of inertia with respect to center of gravity. Then E, center of gravity of semicircle. Let us draw the semicircle for our reference. H is the radius and 2b, that is from origin to end point of the semicircle. This H is equal to B. At the center, it is B. There, in sine curve, H is not equal to B at center. That is different. Here, H is equal to B. That is the difference between a semicircle and a sine curve. Now, just by imagination also, you can say whether this value will be higher than the sine curve or lower than the sine curve. The moment of inertia is calculated. The center of gravity is at a higher height or lower height with respect to x-axis. You can find out all these values ICG, IXX, IYY. For a semicircle, center of gravity, just see y bar. Whether this y bar is equal to the previous y bar or not. See the video, like the video, subscribe to my channel, and then put your requirement in the comments. See the video, like the video, subscribe to my channel, and then put your requirement in the comments, and I will explain for the semicircle. Best of luck to everybody. It's Ramchandra from Civil Mech Maths Concepts channel, and please view my other videos also for FE, PE, exams, and GATE, UPSC ESE exams. This lecture will be useful for moment of inertia. Like this, I will take out many. Please subscribe to my channel, Civil Mech Maths Concepts. Thank you for listening to me. Thanks a lot. Best of luck to everybody.